So here we are, our first video note sheet. Hopefully we'll be able to understand how this works. I have to apologize. Sometimes the cursors and all the styluses don't come out perfect, but hopefully we'll be able to work through these together. But here's the first time that I'm going to be going over a lesson on a video, and then we will be progressing forward with some activities based on this to practice. Please copy down everything that you are seeing, listening to everything that I'm saying, and if there's any questions that you have after any of this, please make sure you ask so that we can make sure that you have everything that you need to do well. So our first lesson is on solving simple equations. So the first thing we need to know is, what are inverse operations? So inverse basically means opposite. They basically are operations that undo each other. So we talk about things that would cancel each other out. So you know a couple of operations already. So if I was to say to you, if I was to add 5 to something and then subtract 5, I would get right back to where I started from. So for example, 7 plus 5 is 12. 12 minus 5 is right back to 7. So the addition and subtraction are inverse operations. They undo each other. Then things like multiplication. And this year we're going to use that symbol for multiplication way more than the X multiplication symbol that you see in the past, mostly because we're doing lots of variable work and lots of times our variables are X's. If I was to multiply something by 2 and then turn around and divide it by 2, I would come right back to where I started. So for example, 5 times 2 is 10. 10 divided by 2 goes right back to 5. So multiplication and division are also inverse operations. They undo each other. So let's just see a couple of examples, and hopefully this will make some sense. So our very first example, x minus 7 equals negative 6. So a couple of things I want you to do so that you can kind of make sure that you understand. So the equal sign, we put this little wall down it. This wall is basically helping me see when I go over the wall that I have to do something to move my numbers. Basically what we do is we do the opposite of what we see to help move it across. The other thing that I would like you to be in the good habit of is I always circle the variable I'm trying to get all by itself. My final answer will be x equals something, and my job is to get everything to the other side. So then I look at my operations and the numbers that have to move. Well, really, there's only one number in this case that has to move, this minus 7. I need to get it over to this side. So again, to move it over that wall, I need to do the opposite of minus 7 or subtract 7. So the opposite would be to add 7. Now remember, anytime I do something to one side of an equation, I have to do the exact same thing to the other side to keep the balance. So if I add 7 to the left side, I also have to add 7 to the right side. Now these 7's on the left, negative 7 plus 7 cancels out because it becomes a 0, leaving me with just the x. And that's what we wanted, right? That's what the goal was, to get x by itself. On the other side, we got to remember our integer rules. Negative 6 plus 7, that gives me 1. So I think that's my answer. But how do I know? The good thing about these equations is I can check it to see that I have the right answer. The way I check it is, we now have x's are 1. So I go back to that original equation, I take x out, and I replace it with what we think is the answer. I plug in all the other numbers that go with it, and I basically do the math and see, does it work? So 1 minus 7, does it equal negative 6? Well, 1 minus 7 is negative 6. So negative 6 equals negative 6, so it checks. That means there is my answer. and I know it's right because I did the check. So let's try a different one. So this next one, we see y plus 3.4 equals 0.5. So again, we're trying to solve for this y. Plus 3.4 tells me if it says plus, I have to do the opposite, which is to subtract 3.4 to move it away from the left side and get it on to the right side. So 3.4 minus 3.4 would cancel and become a 0. That would leave me with the y that we're looking for. On the other side, 0.5 minus 3.4 is negative 2.9. And again, how do I know that's correct? Well, if I plug it in, I would get negative 2.9 plus 3.4. Does that equal 0.5? It does work. That would tell me that I do have the right answer. All right, one more up top here, and then we'll kind of keep moving down. So this one's a little bit trickier because now I see a fraction and then a variable. But remember, anytime I have a number next to a variable, this means multiplication. Okay, so with that in mind, the opposite of multiplying is dividing. So what I'm going to do is I'm going to divide by negative 3/4 on both sides. And then that's going to get this negative 3/4 and this negative 3/4 to equal 1n. And that's what we want, right? We want that n by itself. Now we have to remember, how do I divide fractions? So negative 2 divided by negative 3/4. Well, if we think about it, negative 2 is the same thing as negative 2 over 1. Divided by that negative 3/4 is the initial part that we're going to look at. Now, if you remember, when you divide by a fraction, what you end up doing is you end up flipping over the second number. So how I do that, remember, is I'm going to take the first number stays the same, negative 2 over 1. We change division to multiplication, and now we flip over the second number. We do the reciprocal. So instead of negative 3/4, it's now negative 4/3. Now we just do multiplication. Now remember, in multiplication of fractions, all I have to do is multiply straight across my numerator and straight across my denominator to get my new answers. If I go straight across my numerator, I'm going to get 8. The two negatives make positive. The denominator is going to be a 3. So there's my answer. I don't need this to turn into 2 2/3. I don't need it to become a decimal. I'm very happy with an improper fraction where the numerator is greater than the denominator, as long as it's reduced as far as it can go. So n equals 8/3 is my answer. Do not turn it into 2.6 repeating or 2 2/3. 8/3 is our best answer for now. All right, here's our next one. Remember when we said we see a number next to a variable, that tells me that we're going to do multiplication. So to undo multiplication, we do division, and the 0.9 is what has to move, so we're going to put that underneath. The 0.9 divided by 0.9 becomes 1w. So right now we're really close to already having our answer. 1.8 divided by 0.09, got to be careful, it's not 2, it actually comes out, and certainly use a calculator for that, is 20. So again, if I was to plug in a 20 for the W, 0.09 times 20 would give me the 1.8. That would be my answer for that. Now it gets a little bit trickier on these next two. These next two have a little bit more involved. These are called two-step equations. I still do the inverse operations. The challenge I have now is I also have more than one operation to move. So how do I know which one to do first? Normally we use our order of operations, or GEMDAS, to decide which order to go. When I have a variable, I basically go in the opposite order. So in this first example, letter E, I see multiplication between the 3 and the x and addition. If it was regular order of operations, I would definitely do the multiplication first. But in this situation, I'm actually going to do the addition first. So once I've decided which ones I'm doing in which order, again, if you wanted to draw that little circle around the x so you kind of see what do I have to move across, I have to move the 3 and the 2. So I'm moving the 2 first because we're going in the opposite order of operations. I'm going to get 14. Oop, I'm not going to get 14. I'm going to change that. I am going to get 12 because 14 minus 2 is 12. Then on the other side, the 2 and the negative 2 cancel to give me 3x. Now I can look at that multiplication. And remember, multiplication gets undone with division. So x equals 4. And again, I can check that. If I plugged in the x as a 4, then I would follow my order of operations like normal. 3 times 4 is 12, plus 2. Is it 14? Yes, 12 plus 4 is 2. I'm sorry, 12 plus 2 is 14, so I know I have the right answer. All right, and then the last one for now. This one I see two different operations, a divided by 3 and a subtraction of 6. So again, regular order of operations would say do your division first, but I know in this case, because I'm solving for a variable, I'm actually going to be doing subtraction first. So to undo subtraction, we do addition. I'd make sure I do it on both sides. The 6's are now canceled. They've been moved over to the right, and I get a over 3 equals 14. Now I can take care of that division. A divided by 3. So to undo division, we would do this multiplication of 3. And I'm using the parentheses because numbers next to parentheses with no symbol in between them basically means multiply. So that's going to give me an answer of A equals 42. And there is the solution to that equation for letter F. If I plug it in, 42 for the A divided by 3 is 14. 14 minus 6 gives me 8, which is what it should be for this equation, so it makes me know I have the right answer. So this next one is kind of like a little bit of order of operations first to combine a few things, and then using what we've been talking about, our inverse operations. So if I look at this first piece, basically they want to know k plus 4 divided by 0.2 is 5. So we want to find the value that makes it true. So the first thing I want to notice is I can put together these numbers first. I want to do that before I try to do anything else. So 4 divided by 0.2 is actually 20. Then I can bring down the rest of my equation. So really all I've done is just kind of simplify the numbers that I can simplify. Now I've got to figure out, okay, how do I move this 20 away? Because again, we want k to be our final answer. I see plus 20. So the opposite of plus 20 is to subtract 20. K equals negative 15. So that would be the answer. Then I would look over here. Letter A is also negative 15. So my answer to make that equation work, the K would have to be negative 15. Our last example, a little bit of a real life situation. So one of the things we want to look at is we have the temperature in a crater on Mars is 0 degrees at 1 p.m. The temperature decreases. That's something we want to understand what that word means. Actually, I gotta get the pen here. It decreases 8 degrees every hour. So not one time, every single hour. And then we want to know, this is always important, what's the question? What are we trying to answer? So when will this be negative 50 degrees? So there's lots of ways to get there. You could certainly make a table and just start saying, okay, at 1 o'clock it's 0. At 2 o'clock it's now negative 8. At 3 o'clock it's now negative 16. And make a table. We can also use equations though. And if we use the equations, you could say that maybe it's a little bit quicker, but you have to understand how to make up your equations. So here's an equation that's already been kind of set up for us. So the change in temperature is going to be how much it changes per hour, like what's the average change in temperature, times however many hours. So that's just a way of thinking about a plan. So let's think about how much it has changed. Okay, so we're looking at from 0 to negative 50. So in our example, hopefully it makes sense that we're looking for a 50-degree change. It's going down, decreases means down, 50 degrees. Okay. Then I would look at, it is changing 8 degrees every hour. So the hourly rate of change of temperature is going also down 8 every hour. What we don't know is for how long. So we're going to say times h. That's the missing number that we're trying to find. So the hardest part about this example is to make the equation, but hopefully that made some sense as we tried to walk through that. Once I have the equation, now I'm just going to do what we just did on the previous examples. I'm trying to get h all by itself. I need to move the negative 8 to the other side. I see times h, so that tells me to divide. And we do it to both sides to make sure that we're balanced. That's going to leave me with h equals, and negative 50 divided by negative 8 becomes positive 6.25 hours. So keep that in mind. So that's how many hours we're talking about. Okay? So really what that means is not 6 hours and 25 minutes. 0.25 is a quarter of an hour. There are 60 minutes in an hour. So really, this is 6 hours and 15 minutes. So that's a little bit tricky, but remember, our decimal system is based on tens, but our clock would be based on 60s. So the question is, when will the temperature be at negative 50? Well, at 1 o'clock, it is 0. And if I add 6 hours and 15 minutes later, hopefully it would make sense that at 7:15 p.m. we would be at that negative 50 degrees. So hopefully this kind of made some sense. Some of this stuff you would have seen last year in seventh grade. It's kind of a good refresher. It's kind of a good reminder of some of the things. The biggest thing is inverse operations help us move our numbers from one side of our equation to the other side. Addition undoes subtraction. Multiplication undoes division. So please, if you have any kind of questions, please make sure you ask, and we'll look forward to seeing you in class.